Hello all and welcome back to Money Makes Games. This is part 7 on creating your very own first game. The game is Pongish and we have a problem. Wanna know what it is? Then come with me. My name is Moni and I make games. So where are we right now? Well, we can spawn 2 players and they can play against each other locally, which is great, but our ball seems to be misbehaving. If you remember from the previous video, the ball would go into a state where it basically just bounces off the side walls for a long time. Now we have tried to fix that by changing the colliders on those walls, but that doesn't quite work, and it feels kind of weird when the ball just bounces in an unexpected way off a wall that's supposed to be straight. So let's see if there's a different way. First, let's set up a test. We'll run this. Spawn our 2 players here. If you're going to test like this regularly, it's easier just to set up 2 walls, but right now I'm taking my 2 players and just scaling them up so I don't have to keep blocking the ball. Now it's a little boring as it just goes and goes and goes. What we want is it to bounce into a wall, so let's change that a little bit. See if we can get a little off center there. Aha, okay. And there we have exactly the problem that we've been having. Notice also how the ball slows down. Now how do we fix this? We've already messed with the side colliders, and that did nothing for us. In fact, it's worse because now the ball moves in unexpected ways. Well, I've played around with it and the answer is actually pretty simple. When we originally set up our ball, for the rigid body, we added a physics material. And the physics material's role is to set the properties for how the outer material of the ball behaves, like how much friction it has, how much of its bounce it retains, and so on and so forth. Now, if I click on that physics material, you'll see that its bounciness is 1, which means it gives back exactly what it put in, so it shouldn't lose energy on the walls. But we also put in friction. Friction means when you rub up against something, you lose energy to that, and sometimes that energy gets released as heat, and sometimes you just see it as you slowing down. So all we need to do here is reduce our friction to 0, and let's go to our walls. We're going to take off that collider we put on and go back to the straight box colliders. Now let's see what happens. Spawning 1 player, human player there. I'm going to make him nice and big, and then I'll spawn a 2nd player and just play against him. Let's see if we can get that behavior on the wall. Whoops, missed it. Now here we've got it running straight against the wall. There's a way to change that a little bit. We can angle the collider on our player or just give it a round edge, but we're no longer getting a situation where the ball actually slows down enough to... There we go. Let's see if we can get it locked into that pattern again. And I think we can call that a win. Okay, but while we're there, let's make a little change to our player. We'll go to prefabs, double click on our player, and let's see if we can change the collider on this just a little bit. Make a capsule collider 2D. Just disable that box collider. Ooh, that is very hard to see. Let's drag it out a bit. As you can see, the capsule collider actually has round edges. So what happens is, if the ball bounces off the edge of your paddle or your player, it won't go straight off, it'll actually go at a slight angle. That just helps keep things interesting. You could have also done something like what we did previously and basically put an edge collider on it and give it a little bit of an irregular shape. Or maybe you could have put extra things on the sides for your player. Maybe your version of Pong has a player that can actually shoot at the other player as well, so you have to dodge the ball and the bullets, and the ball could actually bounce off those protruding guns over there. So there's room here to play with. For now, I think we're just going to go with a switch to a capsule collider, and when we go out there, we just say save. If we went back, it would have asked us. We can also enable autosave, and that'll just save it for us each time we go out of prefab mode. Okay, we'll test that later. Now what we want to do is have a player that's actually an AI player, so that if we play alone, we can play against the AI. How do we do that? Well, we basically do it the same way we did with the human player, except now we need a script to tell the player where to go. So let's grab our human player here. Let's put him in the screen. Call him AI player. AI player. Oops. Okay. We've got a player input on there, which we won't need, but first let's unpack this. We go prefab, unpack completely, so now it's no longer linked to this. Okay, let's rotate our AI player and put him on this side. And let's have a look at this player script and see what the inputs look like. Okay, so our player script has all this stuff in to let our player move, and it basically just gets input with on move. which is the human part. So if we create our AI, we can just send signals to onMove without changing the player script, and that should take care of moving our player or our AI player up and down to try and match the ball's position. So let's try that. Alright, let's go to our script and say create C# script. We'll go player AI. There we go. Now we know this will only be an analog of real AI, but yeah, it's good enough for the game. If you really want to do something interesting, go find out about Unity's machine learning and teach your player AI how to really play Pong. For now, we're just going to make it basically try to match the Y of the ball position, and then to not make it impossible for us to play against, we'll put in some randomness there to allow it to sometimes miss the ball or be off by a little bit. Come on. There we go. Now our ball is in the scene, so we can grab a direct reference to the ball. And serialize field. If we had a ball that respawned every time, we'd have to find a better way to find the ball. Like getting a notification when a new ball is spawned or something like that. But fortunately for us, we don't need to do that. All we need to do is serialize a reference to the transform of our ball. And on a good day, we'll even spell it correctly. Okay. We'll call that ball. And we need to get a player script. We might actually not even need to access the player script. We could just go transform dot position equals. Now here we need to create a new vector3, unfortunately, because we can't just go ball position vector3, because we want our own. And then our own Z, but we want the ball's Y position. Oh my goodness. Transform dot position and transform dot position dot Y. Okay, We can grab the Z, although because this is 2D, the Z doesn't matter that much to us, and I'm just going to make it 0. Alright, so we're not even manipulating the player script right now. And what should be happening is that this should now just go and directly match the ball's position. Let's see how that works. I suspect this is going to be a problem. Let's just try. Okay, I have my player AI here. Let's just collapse everything here so it's easier to read. We do not need a player input on this. In fact, if we keep the player input, we'll have a problem spawning extra players for the local multiplayer again, as I described in my previous video. And then we'll just go player AI. I could have also just grabbed the script here and actually dragged it on like that. Let's grab a reference to the ball and see what it does. Okay, I'm going to just spawn a player to play against it. And let's see what happens when the ball gets too close to the top. Okay. Well, that's a pretty solid Pong player we have there. It is of course not limited. You see, when you disable the player script and just use that little AI script, it actually goes straight through the walls. So the player script is still stopping it from doing that, which we worked on earlier, but this isn't very interesting right now. It's a good tool for testing because it'll always return the ball to you, but it's always going to be spot on and 100% accurate. So we have two ways we can approach this. We can go without the player script and just do limits for the AI player script so that it doesn't actually go off screen. We can also use the player script so that it's got those safety rails on its own and just give an input, which is going to be easier. Now if we use the player scripts on input, then we're going to have to create an action and pass that to it, because if you look at this player script, come on, it's got callback context and context. So we'll need to create a callback context, which means we'll need an action and all sorts of things for input. That's not really going to work for us. We could add an extra function here for AI move and just tell it to move up by this much or this much and still obey the speed rules. But it feels a little clunky. So I would say let's steal some of this code over here just to make sure that it stays within the limits. And then we'll figure out our own code to do the ball following and add some randomness. Okay. Let's see, what do we need here? We need the camera height. We need that Y offset. We don't need that log statement in either one of these anymore. So we'll take that out. We'll need those offsets to be set. And we'll need this without the current input. Alright, so let's grab this. We'll grab that. Put that in start. Main Y and main X. We need those. Where are they? Oh, it's max Y. That's why. Alright, so we need those two to be declared here. Alright, and for reference, let's grab the code we had in update. Throw that in there. And now we've got a whole lot of other variables. We've got new position, current Y, and speed. New position. We've got a vector 3 new position and a vector 2. That's very interesting. We need the vector 2 one, I think. Okay, and we need speed. Speed's important because maybe we want to slow down our AI player to miss the ball on fast rounds. Makes him a little bit less of a threat. Or we want a fast enemy player so that it's harder for us to get past them. And then new Y and new position. Okay, so let's see. We're not going to need the current input, but we do want to try and match the position of our ball at the end of the day. If we take that out, that basically just makes the input 1, because now the speed at which we move is basically just speed called speed times time to delta time. Now we want to set our position to be equal to this. We want to move towards that at that speed. Okay, there we go. Let's leave that in for reference. Okay, so what we want to do is basically move towards this point here. Now let's grab that new position we have. And we'll set that equal to this. Notice our new position was declared as a vector 2, but Unity basically just takes a vector 3 there and drops the Z. See if we can get away with doing that too. There we go. Now we want to aim towards that, so we'll go transform.position equals vector 2 dot move towards. This basically means that it's going to calculate a position on the way to this based on how fast you can go in each frame. So we're going to update the position, or the new Y position for the ball each frame, and then we're going to try to adjust the player position taking into account the speed in each frame. So we already did some of that. We wanted that position, and we want the speed times time dot delta time, like this. So we'll go to let me just show you. It wants our current position, it wants the target position, and how fast we're going. So, or what the maximum distance is that we can travel actually. So we're going to take our transform.position as our current position, basically where our AI player is. Our target position is new position, which is our position but with the same Y as the ball. And then the speed is just going to be our speed variable times time dot delta time. And that should move our player, or our AI player. Let's go save. Okay, on the AI player, we no longer need the player script, so we can take that off. We haven't taken into account the screen limits yet, so we'll have to fix that. But for now, let's stay with this and see how our AI player does. Okay, so on the right hand side, this is me. Normal player, AI player is keeping up with our ball. Let's see if we can give it something a little more interesting to do. Now you can see it almost missed the ball because of its speed. it can't move up and down quite so quickly. And there we go. So that's one way to make your AI player not perfect. You can also put some randomness in there and say, if the random number generates a number that's below this value, then don't move in this frame, which is something you can also do. Now let's make our AI player faster. Let's get back in the go. Oh my goodness, what did I do? I created an extra human. That's because I've got my keyboard set up. Let's just delete this human. Which one is it? There we go. Delete that one. That's it. That shouldn't happen in your game, but obviously it's happening here because we have our listener on. Okay, let's stop the game and we'll set our player here. Now we've got an AI player that's super fast. So let's see if it's easier or harder. I would say harder to play against. Okay, the AI player is moving slowly, but that is actually just because we are there we go. The ball's moving up and down slowly. Now, as you can see, it's fast enough to match the ball no matter what's going on. And that's it. Okay. That's successful. We just need to have those constraints quickly. Okay, so here we constrained it by taking mathf clamp, and we clamp the position between the y, or we clamp the y position that we set there between the minimum and the maximum, which we calculated up there. How do we incorporate this in here? We've got to move towards for our new position. We could actually just clamp it right there. So the Y is the ball position, but we clamp it, or we limit it to that minimum and maximum position we have. So clamp, the value we want to clamp is the ball position. Remember, this doesn't actually directly affect the ball position, but it takes that value as an input, it clamps it, and then it wants the minimum. So do not go below this value, and do not go over the maximum. So it will just give us a number between that minimum and maximum that corresponds to the ball's Y position. So if the ball is outside the minimum and maximum, it will give us the closest one. Otherwise, it will just give us the ball position. And that should do it, and actually keep our AI player on screen. Oh, there we go. Come, let's see if we can get our... That's it. AI players staying on screen. That should do it. We'll make him a little slower. We could probably make the AI player go the wrong way as well. Let's just have a quick look. So you put a negative speed value. I suspect it will just, yeah, completely go the opposite direction of the ball. In fact, I think we have completely lost our AI player. So watch out for that. Alright. We'll give it a speed of 3. So it's a decent opponent, but not that great. So we have an AI player. Now all we need to do basically is to go to our player input manager. We'll start with the AI player on screen, but as soon as the second player comes on board, we actually want to remove our AI player. So we'll go to the script for our player join detector. Like this. Player join detector here. And here where we check if we have a second player. So basically if we are adding our second player, then we want to do the behavior that will remove the AI player. Now because this is now a multi-line if, we're going to have to use our brackets. And we'll just go find object of type. And we'll specify the type as AI player. Oh, there we go, player AI. And we'll go is active and enabled, and we'll set that to false. Which we can't do. So I'm guessing just, yes, of course. Here we go. Find that, and if you go find object of type, it's actually going to refer to the mono behavior. So you want the game object on that one. We'll go game object dot set active, and we want to set it to false, and that will disable the game object for the AI player. Oh, later on when we round off this game and actually put in a menu and just reset everything, make it all better, we will have to remember to re-enable our AI player. Let's test this, and then we're going to say goodbye. Okay, I've got no player. Touch the controller. There's my first AI player. And second AI player. Second. My apologies. I added my first human player, and there's the second one now under my control with no AI player. You can see it disabled here. And that's it. Mission complete. If you like what I did here, why don't you go ahead and hit that like and subscribe for me. Just like that. Just like that. And then I'll see you next time. Until we meet again, my name is Mani, and I make games.